All right, in today's lesson, we will be learning how to solve exponential equations using logarithms. You solved exponential equations using logarithms in Integrated 3. We're going to add a few new types, and so first we'll review some things you may have seen in a previous course. Okay, so when we can't solve by getting like bases, we want to first isolate your exponential piece, okay? We're either going to take the log or natural log of both sides, and in this class, we always want to write our answer in exact form, typically. Decimal form if we are have some type of application or word problem. Okay. Now, in your textbook, if we have a base 10, they're always going to want you to use the common logarithm. Okay, so log base 10. Otherwise, they're going to want you to take the natural logarithm no matter what the base. Now, technically, you can take the natural log or common logarithm here. I'll accept either on the test, but just when you are checking your answers in the back of the book, note that they will be giving their answers in natural log form, but either one will be okay. However, in example 1, we first want to divide by 2, recognizing that we do need to isolate the exponential piece. And since we do have a base 10, we're going to take the log or log both sides, base 10, which allows us to use our properties of logs, bringing our exponent down. And then you may recall the reason why we wanted to do log base 10 is log base 10 of 10 goes to 1. So essentially we can simplify the left-hand side of the equation to 9x equals log of 29 over 2. And last, solving for x. And this would be our exact answer. Now, do notice that if you are checking your answer in the back of the book, they could rewrite this as 1/9 log of 29 over 2. Also, a 1/9 in front could be brought up to be an exponent, log of 29 over 2 to the 1/9 power or 9th root. Not that I would expect you to rewrite that expression, but hopefully we recognize all of these answers are the same. The first one is just fine. Okay. All right, the second one, we have a base 2. So we are going to, following the book's rules, we want to natural log once we get the exponential piece by itself. So we can add 5. And divide by 3. After we get that isolated, we will ln both sides, natural log, which allows us to, again, bring that exponent down to the front. Now, a very common mistake, few mistakes you want to be aware of is be sure you are natural logging or lineing both sides. A lot of students will drop this off on accident. Also beware and always put these parentheses in place here. The natural log of 2 is being multiplied, by the expression x minus 1. So we do need those parentheses. Now, 2 different ways to solve. In this case, we could distribute the ln of 2 and then isolate x. But in this case, it is simpler, in my opinion, to divide by ln of 2. And add 1. And there's our exact answer. Now note if you did choose to log both sides instead of lineing, the same answer you will get except just log base 10, and that is an appropriate and correct answer as well. All right. The next one, We have a log base 3. So we want to ln both sides. We already have that isolated, allowing us to bring down the x plus 1. And we want to remember the all-important rule. Can we take a log of a negative? No. So this, if you did plug this into our calculator, it would give you domain error. We cannot take the log or ln any log of a negative or 0. So right away when I see I have to ln a negative 2, I know this is going to be no solution. Okay. And remember on our tests, we'll typically have this on a no calculator section, so you'll have to remember that without using a calculator. Although you could technically solve for x, it is no solution. We need to recognize that. Alrighty, next problem, we have e, base e. So we want to be lining both sides, definitely, especially with e, as we will see in a second. First and foremost, get the exponential part by itself, dividing by 20. Okay. And we'll rewrite this as 5 equals e to the 2t, in which now we can lin both sides, allowing me to, again, bring that exponent down in front. And remembering our rules of logarithm, basic logs, ln of e will again go to 1. So we're left with 2t equals ln of 5. So t can be written as ln of 5 divided by 2. Now remember, we can rewrite this as 1/2 ln of 5 or ln square root of 5. Any of these answers will be appropriate. All right, next page. It'll be a while. Do you want to come back? Yeah, okay. All right, so the back side, these are 2 new problems that we did not see in integrated 3. So you may recognize this looks a little different because we have 2 exponential pieces. We have e to the 2x and e to the x. We cannot combine these. Do not try to combine these or subtract them. This is like taking an x squared minus an x. They're not like terms. They cannot be combined. Hopefully, we can see we can do a u sub with this. It's a fancy u sub, okay? I can let u, equal e to the x. So this is a newer u sub. You can see if I have e to the x and square it, that's where I'm getting that first term. Let me rewrite it like this so you can actually see the u sub a little easier, okay? So it is in what's called quadratic form, like you saw in IM3, okay? So we can rewrite this as u squared minus u minus 42. Now, as with all u subs we've talked about before, if you see the factoring without using the u sub, feel free to do that, but I think most students like to rewrite this in simpler form. Go ahead and factor. We'll have u minus 7 and u plus 6. So u is going to be equal to 7 and u equals negative 6. At this point, remember to plug back in your u sub, which was e to the x. We want to solve for x. Okay. And solving these equations, we will ln both sides, again, allowing me to bring this x down. So we'll get x natural log e equals natural log 7. Again, natural log e goes away to 1, I should say. It is equal to 1. So I have natural log of 7 But when we notice we ln both sides here, I'm linning a negative. This is no solution. So we cross that off. Okay, so we just get the one answer, ln of 7. All right. Now this last example, we have a new type of problem because we have an exponential on both sides with an x. So it's going to create a little bit longer of a problem. We still want to ln or log both sides. Okay. Again, bringing down the exponents on both sides. So we get x minus 1 times ln of 4. Please be sure you put those parentheses in there. Ln of 4 is being multiplied by both x and negative 1. Bring down the x plus 2, add your parentheses, ln of 3. Okay. Now, similar to problems we've seen in the first chapter, where we have now this equation where I have to get x isolated. If I have two x's, I've got to do that trick where we're going to distribute, get our x terms on one side, and factor out a GCF and divide. Similar to those difficult inverse problems we saw in Module 1. So first we're going to distribute ln of 4, ln of 3. So we get x ln 4 minus 1 ln 4 equals x ln 3 plus 2 ln 3. Okay. So this is where we recognize the two terms with the x's I'm going to get on one side. So I'm going to subtract this guy over. And then I'm going to add the ln 4 to the other side. Okay. So I've grouped my terms with the x, and we do our factoring trick, taking out our GCF of this x. Okay. So we get ln 4 minus ln 3. Last but not least, we get to divide by what x is being multiplied by, and write our final answer. All right, now technically you could use your laws of properties of logs to condense and rewrite this, but it's easiest just to leave it. And we have our nice answer. Okay, so just remembering our parentheses, distributing, grouping those x terms, and we're all done. Hope that helps, and we'll see you tomorrow.